All right, let's do it. Geometric sequence is a sequence where the blank between any two blank terms is constant. It's not a difference anymore. It is now a, anybody remember? Ratio. The ratio, horrible handwriting. Still looks like a Y now. The ratio between any two blank terms, we're going back to the same as yesterday, consecutive terms is constant. Put simply, when you learn geometry, they tell you, it's just a sequence where you multiply by the same number every time. I'm sure we feel pretty good about that. There is one more letter that gets thrown into it today, and that is the letter R. And R is the common ratio. We use a lowercase r just like we use a lowercase d for arithmetic. Example, state the first 6 terms. We get our U1 and we get our R. We have our first term and the ratio, which means it's time to get multiplying. Term 1 is 1. Who's gonna be our sequence master for this first question? And shout out all the answers. Reina, my champion. 1 times -2 is?
-2.
Times -2? Or times -2 again, which is?
4.
Nice, and then?
-8.
That's 4.
16.
That's 5.
-32.
That's 6. We're good. 6 terms. Nice. And you got to do the easy one. Luke or Jack, one of you guys or both, maybe you can put both your brains together. What comes after 8 if we have a ratio of 1/2?
4.
Nice.
2.
Nice.
1.
Nice.
1/2.
Yeah, one more.
1/4.
Ooh. You guys are such a great team. And we've got one question left here. 81, -1/3. Who's got the guts? Devin Grady.
-27.
Yep.
9.
Yep.
3.
Yep.
1.
Yep.
-1/3.
Yep. Not too bad, right? We're good? Next. Notice if the ratio, I'm not sure why there's a period there, maybe it's just a typo. If the ratio for a geometric sequence is blank, then the terms will shrink and approach 0. We're gonna put -1 less than R less than 1. In other words, if the ratio is smaller than 1, I don't care if it's positive or negative, it's gonna cause us to shrink, which makes total sense. We're being multiplied by a small number, or less than 1, we're gonna be going down. Great. Also, a lot of notes will say like, if you have a negative number, you will bounce back and forth from positive to negative. Of course, right? I don't think I need to write that down. I'm sure you guys know what's up with that. Definition. A general formula for the geometric sequence, again, pretty similar. We got this yesterday for arithmetic. It is the general term is equal to the first term times the ratio to the power of n-1. And that makes total sense. This is your term finder formula. It will help you find the term that you want. It will help you skip ahead to the future. If you had to find the 80th term, it could help you do that. And to put it simply, you start with 1 and you multiply by R n-1 times. You start with the first term and you multiply a whole bunch, right? That's all that it is. For arithmetic, it is repeated addition. which upgrades it to multiplication. And for geometric, it is repeated multiplication, which upgrades it to exponents. Anyways, we continue. Example. Let u1 equals 10 and u10 equal 196,830. Of course, geometric, growing very fast. You get some big numbers. And so we need to find the third term. Now, if you're ever doing these questions and you're starting off, you want to think about the difference or the ratio. Do I know what that is? If you can start with the first term and the difference, you can get anywhere. For this question, do we have the first term? Do we have the difference? It's not even an arithmetic sequence. Do we have the ratio? No. So to me, our first goal is to find the ratio. How can we use all the stuff we have to get it into some formula that has an R in it? Probably the only formula we've talked about today so far. We're going to use the general formula, which is u sub n equals u sub 1 times r to the n minus 1. We're going to use all this information that we have. 196830 is equal to 10 times r to the power of 9. 9 because, of course, 10 minus 1 is 9. Divide both sides by 10. I'm just going to cross off the 0 because that's what divided by 10 does. And how do we get that r by itself? How do we get that 9 away from the r? We need to take the 9th root. Weird, but not very hard. We need to do the 9th root. Again, I crossed off my 0 because I divided by 10. Maybe that, is a little bit too shorthand, but trying to go quicker on the notes today. Do you know how to type the 9th root into your calculator? You can find the nth root. There is a button on the calculator. The way I always like to do it is type it in like this. 1968 3 to the power of 1/9. Of course, a fraction exponent. What is it? Well, have you seen the answer yet? What is it? What's the real answer? 30. Sig figs for all of IB on the test is 3. So 3 will always be good. But the answer is just a plain 3. Did you type in the 0 on there still, maybe?
Yeah.
No 0.
Oh, I just minus. Yeah.
Okay. Now, that's not the answer though. Find the third term. The third term would be the first term times 3 to the power of 3 minus 1, which is 2. This is the answer. This is only the r, not really what we quite want. Feeling good? Okay. The formula used to calculate a geometric series. In our formula booklet, u sub 1 r power n minus 1 over r minus 1. There's actually 2 in this formula booklet. U sub 1, 1 minus r power n, 1 minus r. What's the only difference between these two things? Sure. Actually, they both work. So I see how you're thinking, right? Basically, the order is different in both, and they both work totally fine for decay or growth. But you are right. I have on here good for. This is good for r bigger than 1. And this is good for r less than 1. So again, Devin is certainly in the right mind when he's thinking about growth or decay. Now, r bigger than 1, is fine. We also can have R be these negative numbers, and so I'm gonna sneak some absolute values onto my R so that I can include the negative version as well, because of course in the negative world we have those numbers as well. Basically, if you think about it, if you had a number like, let's just say 10 minus 1 feels very natural here. But if you put that same number into this formula, 1 minus 10 is just a little bit less natural, right? All of a sudden you get, right? It just doesn't quite work as nicely. Then over here, if we try a number like, 0.5, again, I don't really like that. 0.5 minus 1, because it's going to be a negative number. However, over here, if I try 0.5, then it's going to be 1 minus 0.5, and it's going to be positive 0.5. So anyways, it just kind of keeps things looking a little bit nicer. Growth or decay, sure, right? It still totally works. The formulas are exactly the same. It just looks nicer. That's the only difference. So let's calculate the sum of this series. Before you do anything, do you have the first term? Do you have the ratio? What is the first term for this series? 2. Do you have the ratio for this series? If you're ever not sure, take two numbers and divide them. You should take the second one and divide the first one. And so take this number and divide this number. So do 4 divided by 2, and their common ratio is 2. Now, to be honest, this question probably, if it was on a test or a quiz, and it was meant to be more specific and more fancy, it probably should say calculate the sum of the geometric series. Otherwise, hey, who's saying that this is geometric? So it's probably going to be stated as being a geometric series. Anyways, it says calculate the sum of the series. We need to go from here up until then. Well, that also requires us, of course, to use the formula, but it requires us to know what n is. What n are we going to choose for this question? What term is 2 power 10? It's the 10th term, right? So that, not too bad. R power, well, I guess I'll write this one. R power n minus 1, n minus 1. Choosing the numbers that we're going for, we're looking for the sum of the first 10. The first term is 2. The n is the number we're looking for. The ratio is also 2. And we're going to go into our calculator and type all this out. This is going to be a fraction, but on the bottom it says 2 minus 1, which is just going to be 1. So it's not going to be a fraction. It should just be a nice whole number. Anybody have the answer? It's pretty big.
2046.
Nice, 2046. Sum of the first 10 is 2046. Excellent. You're right. Moving on. Calculate the sum of this series. Same thing. Do we know what the first term is? Do we know what the ratio is? The first term is obviously 1. Who's got the ratio? Genius. You guys are so smart. Again, if you're ever not sure, take the second one and divide the first one. Again, there probably needs to be some more instructions on here that says this is a geometric sequence, geometric series, but whatever. It doesn't say that. We'll be all right. Let's say S sub n is equal to U sub 1. This time I'm going to switch it around because we are less than 1. So I'm going to put that 1 first. I'm going to go back in and get my numbers where I want to be now. What is the value of n for this question? It's not 2, the value of n.
Oh.
11. It is 11. Last time we started with 2, 4, 8, 16. up to here, but this time we have this 1. You could kind of think about this like it's 2 power 0 on the bottom instead of 2 power 1, which means we have 1 through 10 and an extra 1. Anyways, just a little bit of a trick question to keep you on your toes. We're actually doing the sum of the first 11 for this question. The first term is 1, the ratio is 1/2. Now this one, again, looks like it's gonna be a fraction, and when possible, it'll probably either say, tell me the exact answer, that means we're gonna use a calculator, probably gonna use a fraction, or if it says round it, then we can round it to it. But let's give the exact answer using the calculator, pressing math frac. Who's got? Well, let's go fraction.
Oh, fraction. 2047 over 1024.
Nice. We got any more on this page? No. Faster, faster, faster. The sum of an infinite geometric sequence. Now, we talked about summing up an infinite sequence on that first day, on Tuesday, but this only works for geometric. If it's an arithmetic, you're either getting bigger forever or you're getting smaller forever. It's gonna be infinity or negative infinity. But for geometric, it could be the case. We already even talked about it here. Result only exists if r is less than 1, meaning the absolute value of r is less than 1, because of course negative numbers would work as well. The formula is u sub 1 over 1 minus r. Again, straight out of the formula book, which is great. Basically what happens is, it's because we're HL, I'll tell you about it, but you kind of start with this formula. And if n is infinity, then that means you're going to be multiplying whatever this r is by itself a billion times. And if that is a fraction, it's going to shrink itself a billion times, and it's going to become infinitesimally small. And then what is 1 minus basically 0? 1. And then, so basically this whole thing just obliterates itself, and you're left over with just the bottom half. Okay. If, here's some vocab, relatively important, could possibly be on a quiz coming up. If an infinite sequence can be summed to a finite, come on, value. That's not bad for this many questions without just a straight up spelled wrong word. Anybody caught any other typos so far? Hey, I'm not too sad to see that. A finite value. Then we say it converges. Right? It kind of works like an asymptote, right? You're getting very close, but at the same time, you're still going to infinity, so you can never say you actually get there. It's kind of weird. So we say converges. Otherwise, the opposite of converges is diverges. You guys ever seen that movie Divergent? I never read the book, but I watched the movie maybe this summer with some friends, and it might have been the worst movie I've ever seen.
Yeah, the movie's really bad.
I mean, it might have been the worst movie I've ever seen.
The movie is really bad, but the books.
I bet 100% the books are great. God, it was unwatchable. Absolutely unwatchable. Anyways, moving on. Show that this sequence summed to infinity is equal to 2. Probably a good idea every time you start. Can you tell me the first term and the ratio? The first term is 1, the ratio is 1/2. It's a very easy formula. 1 over 1 minus 1/2. That's 1 over 1/2. That's 1 times 2 over 1. That's 2. Whatever, use your calculator, right? This is just algebra using keep, change, flip, dividing fractions. We're moving on. Finally, we get what we were all waiting for, a couple of harder examples just to make sure we're not doing geometry, we're actually doing some IB stuff here. A geometric sequence has the 5th term equals 3 and the 7th term equals 0.75, 3/4, whatever. What is the first term and the ratio? Now, sometimes you can look at these questions and you can just tell. Oh, I think the ratio is 2. I think the ratio is 3. I think the ratio is 1/2. Sometimes the ratio might be 4/7, which is awful, and you probably won't be able to tell. So how can we do this without basically just knowing it? I think there's quite a few people here in class that could probably just look at this and say, oh, well, the ratio is obviously 1. Well, in order to figure this out, I definitely want U1 and R. I don't know either one. So I'm gonna go ahead and do like a system of equations with my 2 variables, right? Very IB, very math AA, they love this kind of stuff. I'm gonna set it up and say, you know, U5 equals U1 times R to the power of 5 minus 1. I'm gonna have another one that says U7 equals U1 times R to the power of 7 minus 1. I'm gonna plug in my numbers that I've got here. I've got U5 is 3, U1 times R power 4, and U7 is 0.75 U1 times R power 6. Again, I think I heard whisperings of people figuring it out already. That's okay, but how can you actually figure this out? Here we have 2 equations that have the same 2 variables, so we can find one and plug it into the other and solve for it and do the whole thing, the typical IB thing. So we can divide, you know, R power 4 to the other side. That will isolate U1, and then we can plug this in over here. 0.75 is equal to, plug it in, 3 over R4, R power 6. Now we've got 6 R's on the top and 4 R's on the bottom. And when you divide exponents, you subtract. So 6 minus 4, we're gonna have 0.25 is equal to R squared. What do you say? I divided by 3 as well. Classic Mr. Collier skipping algebra 1 steps. Sorry about that. We're just moving on. We need to get rid of that squared, and so we need to square root both sides. And I have to say, I did hear some whisperings, but the whisperings were wrong. The ratio is not 1/2. Why not? It certainly looks like it's 1/2.
Positive.
Yes. Positive or negative 1/2. And as much as that's, we always have to do this lame positive and negative thing whenever we square root both sides, and the negative answer never works anyways. Actually, the negative answer does work, because if you multiply it and turn it negative for the 6th term, it will turn back positive for the 7th term. So this negative is a totally valid ratio. So now, when it asks us to find U1 and R is equal to truly 1/2 or negative 1/2. There's 2 totally valid sequences here, and we kind of have like a branching multiverse going on. We do need to find U1, and so we can use our general formula that we can use either one, the 5 or the 7. I'll probably use the 5 here. 3 is equal to U sub 1 times the ratio. We can choose either one. Actually, we'll need to find both, but it's easy to find both. And then 5 minus 1 is 4. That would make 1/16, and then we'd multiply by 16, and that would give us 48. Now we need to be careful, because again, we could also have a ratio of negative, but even if it's a negative 1/2 to the 4th power, still gonna turn out to be positive 48. So we have two ratios. It could be a 1/2 or it could be a negative 1/2, but there is guaranteed only one first term, right? The way it works is that for this sequence, the 5th term and the 7th term are positive numbers, and so the even terms between the odd terms could be one or the other. But since the first term is odd, just like these, they're guaranteed to be positive. Maybe I'm going over your head a little bit. Find U10, it should now be pretty easy because we have the R's and the U's. U10 is equal to the first term times R power 9. Now that's gonna be a pretty nasty fraction. Let's just go with decimals, especially because they started us off with decimals here anyways. Anybody got, it's like pretty weird decimals, got 0.9 or something like that, 0.09. Anybody got it? Oh, come on, 48 times 0.5 power 9. 6 clicks. 48 times 0.5 power 9. 0.09. 0.0938 sig figs. Does that work? And we also need the negative version of this number. Making the 1/2 negative just makes the whole thing negative. So positive 0.0938 or negative 0.0938. So here are the answers for this question boxed up. All right, just like yesterday, they can ask you a funky IB only consecutive terms question. It says the consecutive terms of 10, x, 90 are in a geometric sequence. Find all values of x, find all values of r. Yesterday, we did second minus first, third minus second, and we set them all equal to each other. We used minus because it's difference. Today it's ratios. So what we're gonna do is second divided by first, third divided by second, and that's all we get for this question, and these should be equal to each other. Solving ratios, because we type,
Thank you.
solving ratios is relatively straightforward. You can use cross multiplication. Using cross multiplication, I'm getting x squared equals 900. What's the answer?
Awesome.
Plus or minus 30. Two valid answers. We don't know if it's guaranteed to go from 10 to 30 to 90 or from 10 to negative 30 to 90. And it's gonna be one of those bouncy back and forth type questions. That's A. Let's get B. Find the ratio or all satisfying ratios in case there's possibly more. Anybody got those ratios? Just take the 30 and put it on one of these fractions. What's 30 divided by 10?
3.
What's negative 30 divided by 10? All right. Here we are. Weirdo math world. To finish off the day, the last thing we're doing. Prove that 0.999999999999999 forever is equal to 1. Which is a bit of a paradox. Right? Because we think, well, this number certainly has to be less than 1 because it's literally less than 1. It doesn't have a 1 and it's got all 9s and it's not 1. The reality is, mathematically speaking, 0.99999 forever is the same thing as 1. It is the same thing. We can prove it There's like 100 different proofs. You can look up other proofs. The one we're gonna do today is the one, of course, that has to do with geometric series. What we're gonna do is first look at this piece here, and we're gonna break this piece up into things that are being added together, okay? Now this, if you look at it without thinking, looks complicated, but if you look at it with thinking, it's not complicated at all. So when you look at this, make sure you've got your brain turned on here. 0.9 with a million nines is the same thing as 0.9 plus 0.09 plus 0.009 plus. What this is that's the 9 that goes in the first place, and that's the 9 that goes in the second place, and that's the 9 that goes in the third place. So again, it looks a little crazy, but in reality, we're just taking each of those 9s and spreading them out. If we're doing it like this, is it a geometric series? Is it having a common ratio to go from one to the next? If we take 0.09 and we divide it by 0.9, what is the ratio for this series? 1/10 or 0.1, however you want to say it. And so we should be able to sum this infinite series with this ratio. The sum of the infinite series is the first term, 0.9, and then 1 minus r. That gives us 0.9 divided by 0.9, and that gives us 1. Honestly, there's even easier proofs that these are exactly the same. Again, it's a little bit of a weird math conundrum, but it's just the way it works. Have you guys ever heard of the guy who goes halfway to the door every step, right? So if I'm going halfway to the door, and then halfway to the door, and then halfway to the door, and then halfway to the door, how could I ever get to the door? Well, you just get to the door. That's just kind of how it works. And so, yeah, eventually the 0.999, you just get there, and it's just 1. There's other things you can use. For example, you know, we know for a fact that this is 1/3, right? 0.33 is 1/3, and if you times this by 3 and you times this by 3, then you get 1 is equal to 0.99999. That's just how it works. Eventually you take 3 3s, or 3/3, and it's all 0.3s. Eventually, somewhere there's that little extra piece that makes 1. All right, that's enough yapping about math paradoxes.